Hi there, everyone, and welcome to Decoded, where we break down complex topics and make them simple. My name is Kirsten Lake.
My name is Lwazi Shamase, and we're about to cover quantum computing. Let's get decoded.
Yes.
Yeah.
Sure. So this is a very complex topic, and it's like kind of like one of those things where you do actually need to be a little bit of a rocket scientist to understand.
Quantum physics, actually.
Quantum physics. So we're going to try break this down as quickly and as easily to understand as possible. We're going to try and not use jargon, and we're going to really try and make this something that everyone can understand, because honestly, this topic is changing the game for us. So This is going to change the way that we know the world today. This is going to change the way that we know AI, the way that we know how even our cybersecurity is going to change from this.
Right.
So let's get into it.
Let's go.
So I first want to start with an analogy.
What is it?
Okay. So the analogy is if you are flipping a coin into the air, is the coin on heads or tails while it's in the air?
You won't know because it's flipping.
Yes.
So it's either 0 or 1.
Or it could be both.
Yeah, heads or tails,
Yeah. So that is literally the basis of the quantum physics behind quantum computing, where it doesn't have to be one or the other. It can exist in a state of both at the same time. Okay. So this is quite difficult to wrap our heads around, is because everything we know up until this point, a light can only be on and a light can only be off. There is no in between.
There's no in between. It's either true, false, 1, 0.
Exactly. But if we break this down to the same behavior as of atoms, and on atom research, atoms can exist in a place and not exist in a place at the same time.
That's correct.
And that's where this all comes from. This whole building of this quantum computer is based on that level of quantum physics.
Yes.
Okay. So that is called a qubit. So in computing, we have a thing called a bit, where it's either on or off.
0 or 1.
Exactly. A 0 or 1. So that's the same as a coin. A coin can only be a heads or a tails.
Yes.
Yeah. So a qubit is a state of a 1 or a 0 where it's both at the same time and neither also at the same time.
Exactly. Yeah.
Okay. So these supercomputers, they look like these golden chandeliers. I'll try edit one into the video of this podcast so the viewers can see, but it literally looks like this golden chandelier, and it's able to do these calculations on such a massive scale. So how this changes the world for us is, I want you to imagine a game map. Okay?
Right.
Now, and the way that you can transport yourself around the game map, or a map of the world, is by your ability to do mathematical problems. Okay? Right. So if you are just using your own mind, that's equivalent to walking.
Yeah, it is. It is. It's an action.
Yes. So you're moving through this map by walking. You are discovering new lands. It takes a long time. You probably will discover a lot along the way. And that's the human mind without these tools. Then we created computers. And that is equivalent to driving, where we can discover a lot more and we can go further distances. We can start building cities and roads and all sorts of stuff because we have computers now.
Exactly. They do the more complex stuff.
Exactly.
For us, better and more efficient than us normal humans, right?
Yes. So a quantum computer, if we're going to put it into this analogy, is like a boat.
Yes.
So we've explored the land, we've walked through the forests, we've driven on the roads. This quantum computer is equivalent to now a boat in the sea being able to explore completely uncharted territories.
At a faster rate.
So now, instead of me driving between two cities, I can now take a boat directly to those two cities.
Yes.
And also along the way, discover a whole bunch of new information.
Yeah, new things, exactly.
Yeah, so that's what quantum computing is about to unlock for us.
Yeah.
And how it does that is, if you imagine a librarian, and she's usually trying to get information, right?
Right.
So she'll usually read one book. So you ask her a question. She'll read one book and she'll scan the book to find the answer. Then she'll read the next book and the next book after that and the next book after that.
Right.
Quantum computing is like the librarian reading the whole library at the same time to find your answer.
In a few hours, if not few minutes.
It would be a few minutes.
Yeah, versus days or weeks.
Exactly.
So it's more of a faster version, because remember, normal computing, it will do what you mentioned, bits, where it goes 0, 1, 0, 1 in a sequential linear way.
Yes.
Right? Whereas us, we have to think about, then execute, think, which us is 0, then 1. Whereas with computers, it's 0, 1, 0, 1 on a faster scale. And now quantum not only takes, like what you mentioned, 0, 1, 0, 1, can do 0, 0, 1, 1, 1, 0, 0, 1. But now it's doing it not only linear, but parallel.
Yes.
I can have 10 of those things at the same time to solve the one problem.
Exactly. Yeah. So would you like to go more into why this is important?
Look, I think it's very important of why it's important, and I want to dive into that. It's very important because think of it like this. It helps us problem solve more complex things that we have than the normal computers. So if I have 10 million computers communicating with each other at the same time, sequentially and parallel, to find the, I don't know, if it's possible to mix Coca-Cola and Pepsi together, it'll find out that perfect formula within a few minutes. Versus if I had to use a normal computer, which it'll get the same job done, but it'll take it probably longer. Like maybe a few days, if not months. And I say why it's very important to know of this is because it's the upcoming technology. And I really think that's where we're heading right now, especially now that we're in the 5th industrial revolution. And if we're having computers integrated with AI to think at that scale, I can input a lot of complex ideas into this said model. But because it's powered by quantum computers, and those quantum computers will speak to various models parallel and sequentially at the same time, it can get me a quick response within a few seconds, no matter how complex I'm actually providing the input for it. And since this is an emerging technology, again, in its original inception, right now, I would say it's mainly used for research purposes. And again, you can dive into that one. Of discovering, for example, how to cure certain diseases and how to actually get the optimal medicine for that said disease to treat it.
Well, yeah. So because of its nature, that it's focusing on quite an atomic level, what we're finding is that within the medical and the health sector, you actually can dive into how your genes work on a more atomic level. So that's going to bring us a whole new array of information, right?
Yes.
Because we're not only going to be looking at the genes, but we're going to be able to look at how the atoms interact with each other. And we'll actually be able to get quicker results on, okay, this is the underlying mechanism behind it. It's going to completely change the way that we do physics. It's going to completely change the way that we do encryption, because now if you think about this, every single time that you put any kind of data on the internet, it's usually encrypted. And this is using a public and a private key, and that would scramble your data in a way that other people can't read. And the only way that it can be read is by using your private key, which is your own password. But now what's going to happen with these quantum computers and what makes it safe is that a normal computer would take millions of years to be able to guess the right private key.
Right, that whole sequence.
The right combination, right? Because your private key is going to be like in a digital world, okay, it's going to be like 20 characters of completely, even longer,
probably
of completely
longer.
different things that are, and to find the right combination in order to decrypt your data would take a normal computer honestly so long.
Yeah.
But now a quantum computer can do that in 5 minutes.
5 minutes.
So now we have to rethink everything. So how are we going to do our banking?
Yes.
Because you don't want your banking data to be decrypted.
Oh no, you don't want that. That would be an absolute
your
disaster.
Password to your bank account being decrypted, your private documents that you upload to be decrypted.
Yeah.
So we honestly, as computer scientists and as software engineers, we need to be extremely careful on how we move forward within the cybersecurity space, because now we need to think of we need to actually use this quantum computing in order to create algorithms that are even more complex that a quantum computer can't solve.
Can't solve, yes. And the only way to do that is actually now start working with that technology during the development process of our solutions now. And again, with cybersecurity, they now need to come up with ways on how to actually combat this. Because again, it could be security breaches can be using the use of quantum computers, which can crack a lot of code very easily and at a fraction of the rate. And now that this emergent tech of AI, now if that gets implemented within quantum computing, that's going to be a very interesting take of what's going to happen.
We are coming out of a technological bottleneck where all of this tech is coming into our hands all at the same time.
Rapid rates.
So I even think that, some of our major problems is like, how do humans survive in space for long periods of time? How can we survive on another planet? How can we manipulate the genes of plants in order to grow on those planets? So if we wanted to inhabit Mars, right? We would have to think about, okay, we've got the entire genome of this potato. How do we modify this in a way that it won't interact with us badly, but we'll be able to survive in a different terrain, for example? We could now use the power of AI and quantum computing to actually solve these problems for us. And this could create an entirely different future for humanity, an entirely different way that we move forward with all these technologies that are coming out. That's correct.
And that's the thing right now in its current inception of quantum computing. Again, we need to discover what quantum physics is, but it's like physics, again, on a larger scale. But now in this instance of quantum computing, again, its use case right now is for research purposes. Again, you'll find them more at your research labs, for example, CSIR here in South Africa, as well as in universities. And look, the application is broad, especially in the biomed side. It's quite broad over there. And again, it can also come down to geographic instances of how deep is the earth, what are the said materials or components that live in the earth that we still yet to discover, but the quantum computer, if integrated well, can actually find these answers. And we'll have to watch that space of how it's going to be implemented in the real life.
And also some scientists have been studying this for years. And now all of a sudden, when the tech companies realize that this technology could be monetized, they're now moving at a rate that, science wasn't even able to discover. So they're discovering things along the way that is actually completely changing the way that we understand physics, the way that we understand the world around us, everything. And now we have companies like Microsoft and Google that are having almost like a friendly competition on who can make the better quantum computer. So because of that, we are going to start seeing the most incredible algorithms. And if you follow any kind of tech accounts on LinkedIn or on Instagram or anything like that, you're going to start seeing that there's new chips that are out for these quantum computers. And these chips are capable of
processing trillions of data per second. It's actually madness what's going on. And again, even from a Chinese perspective as well, I mean, the technology that's coming out of there, I think they're actually using quantum computing over there at the rate of the technology that's coming out in such a short time. So I think as the world's adopting that, it'll be very interesting to see the tech that's going to come out into the market, and we're going to be there to see it.
Definitely. So keep an eye out on the market. Make sure that you
stay informed.
Stay informed. Realize that the world is changing and it's not something to be afraid of. We're going to unlock all new things. So keep an eye on the space. Do your own research on quantum computing. Check out the new chips and let us know what you think in the comments.
There we go. And that's our episode for today. My name is Lwazi Shamase.
And I'm Kirsten Lake.
And we just got Decoded.